Hello students, today we will learn some basic preliminaries, some basic definitions of vector calculus. So the preliminaries of vector calculus, it includes the scalars and vector fields, and I will start with the definitions of scalar and vector field, the examples of it, the pictorial representation of scalar and vector field also. So let's start with this. Now look at this. I'm going to define what is a scalar field and what is vector field. Now look at these two pictures. This is a pond and this is a river. So clearly every particle, every water particle exists in the pond or static mode. That is, they're not running. They're in a static mode and they're stopped at a fixed point. But in case of a river, if we show the river, if we see this river, each and every water particle it is running. So the flow of the river, the flow of water in this river is from this direction to this direction. We will see here. So the difference between a pond and a river is the particles, the water particles in the pond is in static mode, whereas in water particle in river is in dynamic mode and it has each and every particle has some direction. So it means each and every particle is a vector, it represents a vector in a river, whereas in pond it is not a vector, it is a fixed. So to define the basic definitions and the basic difference between this scalar field and scalar and a vector, the scalar field and a vector field, we can start with this example. So a field means it is not a play field, it is not a playground. A field means it is some points. There is many points exist in this pond and many points, many water particles. We can represent these points as water particles or the water molecules. So many molecules exist in the point. This I'm not talking about a single point. I am talking about many points together. So in this pond each and every particular static mode, and in this river each and every particle are in dynamic mode and it has some direction and some magnitude also. Okay, now look at this picture. This is a picture of a scalar field. Now to define this scalar field, this is if we define, suppose this is represents this contour graph. This contour graph or contour representation represents the temperature in a room. So we can consider this box as a room, and this is each and every corner of this room has some different temperature. So this is this x-axis, and if there is a y-axis, then each and every corner of the room, that is a corner of the corner of the room has some different points, has some different coordinate, and if we denote this coordinate with some temperature, that is, suppose in this corner the temperature is low, this corner this temperature is high. So now look at this scale, plus 4.459, this is a high temperature, and minus 0.382, this is a low temperature. So now easily we can notice which corner has a low temperature and which corner has a high temperature. So similarly, this is a red. So red is means it is a high temperature, and this is blue, and blue means it is a low temperature. Now if we denote this point, if we denote this point as, suppose it is 1 2 3 4 5 6 7 8 9, so it is a 9, and in the y-axis direction it is 1 2 3 4 5 6 7 8 9 also. So we can see that this 9 point, if this point is a 9 point, then it has some temperature which is in between this section, that is minus 0.382, and some this section in between this there is a 0 point, and this some, suppose this is minus 0.29 something. So in between this direction, the temperature lies between in this region. So this 99 point of this room has a temperature of which is lying between this portion of this temperature. So similarly, each and every point of this room has some different temperature. So temperature is not moving, it is different in each and every point of this room, but it is not moving, so it is a scalar field. So we can define this scalar field in a more pictorial mode. Now suppose this is a room, and this is y-axis, and this is x-axis. So now we define the temperature in this room in each and every direction. Suppose this corner, this is suppose 10, and this is suppose 10. So obviously this corner of this room has the coordinate 10 10. So this corner of this room 10 10, we can define a temperature here as suppose 100 degree centigrade. Okay, and suppose in between here this point of this room, this is suppose it is a 5 point. At 5 point we have a temperature. At 5 point we have a temperature, suppose this 100 degrees is 50 degree. So we can define in this room different temperatures at different points, and if we plot this in a graphical plane, that is obviously it is a 3D diagram, and this 10 10 5 5 point, this 10 10 point, it will be in this plane, and we can consider a z axis like this, and this z axis it represents this temperature 100 degree, 50 degree centigrade, or some other point. If there is some, suppose this point it has some 10 degree centigrade. So if it is in 10 10 point, the temperature is 100 degree. So 10 10 point lies on xy plane, but this 100 it is in z. So obviously, and 5 5 point, this is this 5 5 point lies obviously in xy plane. Similarly, this point lies in xy plane. So every point like this, each and every point lies on xy plane, but the temperature at this point is represented by this z axis obviously. So it forms a diagram, a 3D diagram, which is called the scalar field. Now come to this vector field. So this vector field, look at this vector field. We already told that in a scalar field, no points are moving. But in a vector field, we see that each and every point, if we suppose these as a point, each and every point is moving in this direction. Now suppose in this middle point, it represents a fan. So obviously, if the fan is moving in this direction, and the air particles obviously moving in this direction, so along with this fan, so each and every air particle, it has some direction here. So in case of a temperature, the temperature it is fixed. Each and every point is fixed in the room. Each and every point if we consider a room, and each and every coordinate of the room, the temperature is fixed. Yes, temperature is different at different coordinates, but at that coordinate the temperature doesn't have any direction. That is, the temperature cannot move. But if we consider this air particle, if we consider this is a fan, this middle point is a fan, and the surrounding air particles are moving along with this fan, then all these particles has some direction, and there is it has some velocity, and we know velocity is a vector quantity, and vector quantity means it has some value as well as a direction. So all these particles are moving in this side. So this is a vector field. So what is the difference between scalar and vector? Scalar, it has every points are fixed. Okay, may be different at different coordinates, but it doesn't have any direction. Okay, so field means it many points together with many particles. It forms a field. Okay, but in scalar all the points or all the particles doesn't have any all the particles do not have any direction, but in a vector field all the particles have some direction. Now this is a example of a scalar field. Now see that this is a scalar field, and uh, just now the look at the contour plot. This is a scalar field plot. This is a contour plot with it is a scalar field, and it represent the temperatures at different points of this room. But I told you that this is actually contour plot. It represents a 3D diagram. But a 3D diagram, if that 3D diagram is represented by this 2D diagram, that is, we just convert that 3D diagram, this 3D diagram with this 2D. We are representing this one with this. So obviously we see that this portion has temperature or different temperature is a high temperature. This portion is a low temperature. So in 3D, look at this. This is a high temperature. This is a low temperature. This is a low temperature, and this is high. So this, if we plot this, that is, if we see this as a 2D diagram, that is just uh, this figure is flattened, and we can see this diagram. That is, this portion, this high temperature portion, this high temperature portion is represented by this one, and this low temperature portion is represented by this one. Similarly, this low temperature portion is represented by this or this one, and this high temperature is represented by this one. Okay, so this is a contour plot. Okay, that is, this picture is completely flattened, and just z-axis is removed. So just like a satellite diagram, when we see a satellite diagram, hilly area, the Himalaya, from the satellite diagram we see the picture like this. The highest peak is represented by this one, this one, and this one, and the valleys they represent by this. So just like this, if we consider this is a hilly area, this is a Himalayan region, so this is a peak, this is a peak, and these are the valleys. So similarly, this and this picture, if we see this Himalayan region with a satellite diagram, obviously we see the pictures like this. This is a peak, this is a peak, this is a peak, and these are the valleys. So now this is the example of vector field. Now the mathematical diagram or mathematical formulation of vector field. So now look at this. So this is a vector field, and we see that now first we show the scalar diagram, the scalar field. Now see this picture. So look at this picture. This is scalar field fxy equal to x to the power 3 by 2 into y. So this is the diagram, 3D diagram of it. Okay, so if we just move this, just change the value of x and y, we can find this one. So by changing this as some other plus x into y square. Okay, so it is changes like this. Now we are changing it like this. Now look at this. So now this is a plot for this scalar field. Now look at this. This is just like that peak. This is just like that peak which I already have shown, just like this. So this picture and this one is almost similar. Now look at this. There is a peak. Okay, there is no peak actually. Okay, if I extend this x and y x y and z axis, there may be some peaks, but we can see those valleys like this. These are, so if we consider it as a lower temperature area, and this upper diagram has a upper temperature area, so it is just follows that picture, contour picture, or that 3D diagram of temperature. So the scalar field, the mathematical representation of the scalar field, it actually can be represented by this one, fxy equal to x to the power 5, where this each and every point doesn't have any direction. So similarly, we can define many other scalar field like this. If we change these functional values, that is x to the power 3 by 2, we already have seen what is the graph of that. Now if we change this function like this, now the graph also changes like this. So now come to the vector field. So this vector field is can be represented by this. So now look at this, the basic difference between the scalar and vector field is these functions. That is, in the scalar field, the functions were like this. There is no ij. If I put here I and j, obviously each and every function has some direction. That is, the particles are moving. So if I add the directions I, j and k, obviously the points is each and every particles are moving particle. It becomes a moving particle. Okay, so just like now in a vector field we are adding this I and j, that is minus y into I plus x into j, that is we are just giving them the direction of it. Now how to plot this vector field in a graphical plane? Now simply we are putting some points randomly. Now in this we are now obtaining the sketch of A. Now putting the values of x and y as half half. So we are getting this is a vector point. Now secondly, we are putting here half and minus half, that is x equal to half and y equal to minus half. Here we now have this point. This is also a vector point. Similarly, we are putting 3 by 2 and 1 by 4 in this function, x equal to 3 by 2 and y equal to 1 by 4. Now these functions give us this. So we have three different values, different vector points. Now we are plotting these points into this diagram, this plane. There's a 2D plane, and we are having this kinds of diagram. Now this diagram can be obtained by extending those values, that is putting some more different values of x and y. There is half of 1 1 0 0 1, like this we are putting those many values, and we are getting this diagram. So look at these diagrams is actually is nothing but this one. So this is a vector field. Now how vector field can be plotted in a graphical plane. So this is the technique, that is, if some vector function, that is vector field function, is given, then we can put a different values of it, and we can obviously use some other programming languages or some softwares, some plotting softwares, to get this graph. So randomly in a software, uh, they can put the every random values of it, and simultaneous random values, putting these values, and they automatically, we can obtain this graph. So this is all for today. In the next lecture, I will discuss about the gradient of a vector field, sorry, a scalar field, the grad, the diverges, and curl, and all the other stuffs related to this topic. Thank you.